Dear students, welcome back to lecture 16th of mobile and pervasive computing. हम डिस्कस कर रहे थे Dalvik virtual machine को and why there was a need of an additional virtual machine when we have Java virtual machine already in place. ये उसी तरह का dilemma है कि why additional components in the kernel itself when there are Linux kernel is already very mature and it has gone through, it has seasoned itself. तो उसी thread को वहीं से continue करते हैं कि why Dalvik virtual machine and what are the efficiencies that Dalvik virtual machine brings on board. लेकिन इसमें delve होने से पहले, just to put everything in perspective, on the screen I am showing you the software architecture of Android operating system. The different layers that Android operating system is composed of. I'm sure you have seen this diagram many times by now, but this is the core of the operating system. At the lowest level, we have kernel, and we have discussed what is inside the kernel and what is not. That is where the kernel has originated from. That is, it's taken from the Linux kernel itself. And the primary reason of doing that is that the Linux kernel itself is open source. So there is no problem bringing it on board to another open source software, that is Android. On the top of Android kernel, there is a set of libraries. We call it native C++ libraries. C++, obviously, because they are implemented in C++, and these are native libraries. That is, this is written in the native code. We call it just as a notion. In libraries को हमने divide किया था into 4 distinct components. We call it that libc is one such distinction, bionic libc. Then we said there are a set of libraries that provide some functionalities to the system. So we termed them as functional libraries or function libraries. Then there were native servers that help us handle our input and output. More specifically, they handle our audio services, they handle our video services, they help us draw surfaces, they help us redirect audio or video. So these were called native servers. And all these together make the libraries that goes inside the libraries layer in Android operating system. On the top of these libraries, we have the Android runtime. And what is runtime composed of? Runtime is composed of the Android virtual machine and some core libraries. And this is where we were discussing that why the virtual machine is important. लेकिन उसमें जाने से पहले एक component जो मैं आपकी libraries में छोड़ गया, that was hardware abstraction layer. And we discussed that why we need another set of abstraction when Linux already have drivers supported inside them. और हमने उसके लिए जो reason दी वो यही थी, जो कि एक bionic libc के लिए भी दी, कि there are certain proprietary material that goes inside Android. Android का जो marketing model है वो मैं reiterate करता चलूँ यहाँ पर कि Android का marketing model is like this, that Google people said, or the people behind Android said, that we will design the whole operating system for you. We will do all the heavy lifting. We will design kernel, we will design libraries for you, we will design the whole operating system, and then the phone set manufacturers will be free to use them without any licensing fees. And they will be free to modify it according to their needs. Now, handsets vary from one manufacturer to other, from one model to another. So there is a significant porting effort there, yes, no doubt, but the core of operating system or the operating system itself has been designed by the Android itself. If you follow Android on the internet, you will find that there are many porting efforts going on. People are even trying to run Android operating system on your traditional laptops or desktops, or on those mobile phones for which this operating system is not designed for. So this is the beauty of open source operating system, that people are free to modify, people are free to change things, and people are free to port it to another. And this was the success factor that brought Android to number 2 in the mobile operating system race. That being that it's free, it's open for everybody, and everybody can play with it. So why go with some proprietary operating system like Symbian, where you have to pay for it, where you have to pay for licenses, where you have cut some deals? Why don't just go with open source and implement it? लेकिन इसमें जो problem है, that is that models vary, and so does the particular version of a phone for different vendors vary. अब एक significant porting effort involved है from bringing this Android operating system from what Android open source has released and taking it to the actual platform. In doing this, you will come across many hardwares that are not standard implementation in Linux. Usually these are those hardware pieces of hardware जो कि आपके normal desktop या laptop पर नहीं मिलते. ऐसे कौन से pieces हैं? Your GPS chip is one of them. Usually you don't have this embedded in your laptop or desktop. Vibrating alert and the component that generates that vibration alert is again missing in your desktop environment. So these are just couple of hardware examples which are not standard in Linux kernel, not standard implemented in Linux kernel, I should say. So इसके लिए every vendor has to do their own implementation. अब ये भी हो सकता है कि you have come up with a very excellent driver of a hardware piece that increase the efficiencies of that hardware. आपके पास GPS ट्रैक करने का या GPS को सैटेलाइट के थ्रू कम्युनिकेट करने का, you have an excellent algorithm, and you want this to implement this algorithm in your telephone, of course, because this will give you edge in the market. Problem ये है कि Linux kernel is open source and it is marketed under a GPL license. GPL license, as I said, is a copy left clause. That is, अगर आप open source GPL को use करते हुए कोई भी चीज़ बनाते हैं, so you have to release that open source again under the GPL license. You have to make it available to other people too. Or of course, you wouldn't want to, as a manufacturer of or inventor of an innovative algorithm, you wouldn't want your algorithm to go to your competitors, because that will take away your market edge. So that's why Android has additional abstraction layer, and they call it hardware abstraction layer, and this goes inside the libraries. इसमें क्या होता है? First of all, Android has some set rules of what it expects from the drivers. जो hardware drivers हैं, what functionalities they are supposed to provide. Android has a very straightforward set of requirements that, okay, if you are a hardware driver, you will provide these functionalities to the operating system. And every vendor has to implement that. It is not necessary that you will find the same set of functionalities in Linux kernel driver itself. So this is one reason. Second, the Android open source is distributed under different license. That is, if you use this open source, you are not bound to distribute it freely. So vendors can implement their own algorithm and still keep their intellectual property rights. So this was the reason behind implementing an additional layer of hardware abstraction. We call it HAL, or hardware abstraction layer. It is implemented in C++, and it interacts with the kernel. It has the driver sets written in it, which interacts with the kernel intent. Then we have the Android runtime, and Android runtime has Dalvik virtual machine and runtime libraries. Let's start with Dalvik virtual machine, and why there was a need for an additional virtual machine. Virtual machine gives you portability. This is the reason we have virtual machines. Java की सबसे बड़ी benefit क्या है, या Java का जो marketing point है वो क्या है? The marketing point is that you can run a program written in Java in any platform, because in every platform Java will install a virtual machine and run on the top of it. So for it doesn't matter whether the computer it is running Windows, Mac or Linux. On the top of the operating system, it will create its virtual machine, and on the virtual machine it will run the program. इसलिए no matter what your platform is, Java is bound to run on all of them. And same is true for the mobile environment. In mobile environment, there is a special version of Java. हमने इसको थोड़ा सा discuss किया था when we were discussing Symbian phones, that J2ME is the variant of Java, जो कि हमें यही same portability mobile environments में भी देता है. So the key of this portability is virtual machine. And the thing that brings on board is write once and run on any platform. You don't have to do any portability efforts. आपको, because the libraries, the underlying libraries in Windows are supposedly different than Linux environment. तो अगर आप the native environment पे अगर आप programming कर रहे हैं तो maybe in Linux you are using glibc, लेकिन आपको Windows पे शायद वो support available ना हो. Windows में it has its own set of the core libraries which you have to use. तो इसलिए इसको you will have to do a portability effort अगर आप native environment में लिख रहे हो. Java की यही खूबसूरती कि आप उसे easily port कर सकते हैं without any effort, क्योंकि एक JVM it will initialize a Java virtual machine और उसके ऊपर आपका प्रोग्राम चलेगा. It makes it success. अब Android went the same way. It said, okay, yes, Java virtual machine gives us portability, and definitely we like it. Problem is that just like with libc or glibc, Android felt that this Java virtual machine is a bit slow. So they decided to come up with their own version of virtual machine. इसकी एक और दूसरी dimension भी है, and that is कि Java itself is free. You can take it from Sun and you can install it on your machine, और आप उस पर प्रोग्राम कर सकते हैं, प्रोग्राम लिख सकते हैं, आप उस प्रोग्राम को डिस्ट्रीब्यूट भी कर सकते हैं. Where Java language itself is free, Java virtual machine is not. Java virtual machine को लिए you will have to license it. अगर आप उसे commercial purposes के लिए यूज करना चाह रहे हैं तो you will have the virtual machine, you will have to license the virtual machine. आपको उसका license खरीदना पड़ेगा. So this was a bottleneck for Android, क्योंकि अगर Android decides to ship Java virtual machine inside its operating system, every mobile phone that is running Android will have to be licensed. या जो भी operator होगा या जो भी manufacturer होगा उसे Sun से या now it's Oracle, उनसे ये license खरीदना पड़ेगा. So this is one reason, and very dominant one, that you don't want, if you are throwing something out free, Android or Google wants it to be completely free without dependency on any third party. तो एक रीजन ये हो गया. दूसरा ये कि Android or the people behind Android, they felt that Java virtual machine is a bit slow. It's not memory efficient and it's not processing efficient. So they decided to reinvent the virtual machine, and they call this new virtual machine Dalvik virtual machine. अब इसको उस मेमोरी के पर्सपेक्टिव से देख लें कि मेमोरी के पर्सपेक्टिव से ये क्यों एक प्रेसिंग नीड है. मोबाइल एनवायरनमेंट में वी आर वे बिहाइंड इन मोबाइल एनवायरनमेंट. आप मोबाइल का जो आजकल मोबाइल एनवायरनमेंट है, यू कैन कंपेयर इट विद अ डेस्कटॉप एनवायरनमेंट मे बी 10 years बैक. आजकल डेस्कटॉप में मे बी यू आर सीइंग DDR3 RAM or DDR4 RAM even. लेकिन in mobile environment we don't even probably have DDR1. We have very slow RAMs in there. तो RAM की access बहुत कम हो. Second, जो space available है for your main memory, it's very less. Where in desktop environment we are probably looking at GBs of RAM, 100 GBs, 200 GBs. I mean, depending on whether it's a simple machine or server grade machine, you will have a lot of main memory available. In mobile environment, maybe 512 MB is your limit. तो एक ये restriction आ गई. अब इसको देखें कि when I will take an example of a typical mobile, जो कि एक normal mobile है, I'm not talking about a high-end mobile, or the memory available in that mobile is, say for example, 64 MB. अब how does this 64 MB gets consumed? जब system load up होता है, Android की हम बात कर रहे हैं, and it loads up low-level libraries, it takes about 14 MB of your space in main memory. तो low levels जो हैं, low level libraries जो हैं, उन्होंने आपकी तकरीबन 14 MB ले ली out of 64 MB that was available. Then comes the time when you are loading up high level memories. It's all booting up process. आपको पता है कि जब हम boot करते हैं किसी भी operating system को, so there are certain set of libraries, there are certain set of functions that goes inside memory so to make the processing faster. So when the higher level memory or high level functionalities or high level libraries goes inside the main memory, they take up another 20 MB or so memory from the Android system. So we are already given up about 34 MB. इसको situation को थोड़ा सा worse करने के लिए, now think of that Android comes with pre-built libraries to make programmers' life easier. आपकी programming libraries जो हैं, जो कि Android के साथ ship होती हैं, they are about 10 to 20 MB themselves. Now you think of yourself कि हम program execution के लिए कितनी memory छोड़ें. And this is a typical, an average mobile nowadays. I'm not talking about too high end, I'm not talking about too low end. We are taking a middle ground and see how the memory gets consumed and then how much we are leaving it for the Android system itself. और इसके ऊपर, on the top of everything, think the biggest restriction that Android environments put is that there is no swap space. Swap space is when main memory runs out, your operating system decides that there are some programs that it should get rid of. Get rid of in a sense that it should take it out from the main memory and put it on the secondary memory somewhere. And when these programs start executing again, it will bring it from secondary memory and put it in the main memory again. So, लेकिन Android में हमारे पास ये leverage नहीं है. Android doesn't support any swap space. So once your program is in, it's in for good, or you have to kill it. There is no alternate in between. अब इस environment में when you have to execute your programs, you have to be very, very careful that whatever is sitting inside the main memory is useful. इसमें एक example हमने पहले देखी थी, libc. And we said in Linux or Unix environment, libc is a very important component that provides the core functionalities, core libraries. And that is loaded every time a program loads. अब जब libc load हो रही है हर दफ़ा, तो it has its footprint has to be very small in order कि आपकी memory जो है वो इस तेज़ी से consume ना हो कि जी आप हर दफ़ा libc load कर रहे हैं और every time you are giving up a plenty, you are paying up the price of having a huge library inside your RAM. आपकी memory बहुत जल्दी consume हो जाए. So same idea goes behind Dalvik virtual machine, that okay, let's do something about this virtual machine to make it very compact, very efficient. तो इसमें पहली change जो की गई, that was okay, let's see what's inside jar file. अब आप अगर फेमिलियर हैं जावा के एनवायरनमेंट से, तो जावा जो है और जावा वर्चुअल मशीन जो है वो जार फाइल को एग्जीक्यूट करती है, जस्ट लाइक आपके नॉर्मल डेस्कटॉप एनवायरनमेंट में एग्जीक्यूटेबल फाइल्स होती हैं .exe. जावा वर्चुअल मशीन टेक्स इनपुट अ जार फाइल .jar और उसको एग्जीक्यूट करती है. नाउ व्हेन दे डाइसेक्टेड अ जार फाइल, दे फाइंड आउट कि देयर इज अ रिडंडेंट सेट ऑफ इंफॉर्मेशन इनसाइड दैट जार फाइल. बहुत सी इंफॉर्मेशन मल्टीपल टाइम रिपीट हो रही है. So they took all the information and manipulated it away so that the redundant information is gone. They call it this new file format a DEX file. Dalvik virtual machine takes input the DEX file and execute it. Process वही सेम रहा. आपने एक जावा का प्रोग्राम लिखा. अब जावा वर्चुअल मशीन और डाल्विक वर्चुअल मशीन को कंपेयर कर लेते हैं प्रोसेस को. जावा वर्चुअल मशीन में होता क्या है कि आपने एक जावा का प्रोग्राम लिखा, यू कंपाइल्ड इट, अ जार फाइल वाज जनरेटेड जो कि जावा वर्चुअल मशीन पर जाकर रन हो गई. ऑन अदर हैंड, व्हेन वी आर टॉकिंग अबाउट अ डेक्स फाइल और डाल्विक वर्चुअल मशीन, वी हैव वन एडिशनल स्टेप इन बिटवीन, एंड दैट इज दैट यू राइट अ जावा प्रोग्राम, इट गेट्स कंपाइल्ड, अ जार फाइल इज generated as usual. उसके बाद the additional steps comes in which analyze the jar file, modifies its format, takes away the redundant information and create a DEX file. And that DEX file is then executed inside the Dalvik virtual machine. So this is one additional step that is brought in to make it efficient. अब जब आपने redundant information निकाल दी तो क्या हुआ? एक एग्जाम्पल को देख लेते हैं. We have a database, let's say for example. और database में आपको पता है कि redundancy is a major problem. क्यों? और ये redundancy problem आती किस तरीके से है कि in every field you put references inside those fields. हर field के साथ मैं उसके साथ reference भी डाल दूं कि जी ये this is the field, text itself, not reference but the text itself. We will put inside the text कि जी ये दिस इज व्हाट इट रेफर्स टू, तो ये उसके साथ ही लिख दिया. जहां भी वो रेफरेंस यूज हुआ उसकी जगह मैंने वो टेक्स्ट स्ट्रिंग लगा दी. इसको हमने डेटाबेस में किस तरीके से सॉल्व किया? वी हैव फॉरेन कीज, वी हैव प्राइमरी कीज एंड वी रिलेट देम टुगेदर. रिलेटिंग, जब हम रिलेट कर रहे होते हैं फ्रॉम वन टेबल टू अनदर, जब हमारे पास प्राइमरी कीज होती हैं, जब हमारे पास ये फॉरेन कीज होती हैं, so what we are doing is that we are creating pointers, we are creating references that okay, if this is the foreign key, go to that table and look it up what is there. Same thing was done with DEX file. जहां redundant information थी सबको combine किया गया and then references were created. So now the modified DEX file has, or the DEX file generated after processing jar file has lot of references inside them, lot of pointers going on. So now you have to be really careful because you know अगर आपने C++ में प्रोग्रामिंग की हुई है, the pointers are the most notorious things because they will point to anything and anything. You can point them to that characters, you can point them to integers, and they will just point because this is their work. They won't make sure that they are pointing towards a right thing. So अगर आपकी DEX file में there is a change, an unintentional change, और जिसकी वजह से कोई reference change हो गया, so then you wouldn't know and your file would be corrupt. So you have to be very careful when generating this DEX file that all the references are correct and when installing everything is on their proper place. So this is the additional step of creating a DEX file that goes inside the Dalvik virtual machine. अब ये तो हो गया कि आपने जो इनपुट के लिए फाइल आ रही है आपने उसको कंप्रेस किया, आपने रेफरेंस क्रिएट किए, आपने उसमें पॉइंटर्स क्रिएट किए. एट द एंड ऑफ द डे यू हैव अ स्मॉलर फाइल जो मेमोरी में बड़ी आराम से लोड हो जाएगी एंड यू हैव गेन्ड सम एफिशिएंसी देयर. अब हाउ डज मेन मेमोरी एफिशिएंसी इज अचीव्ड? मेन मेमोरी एफिशिएंसी को डिस्कस करने से पहले लेट मी डिस्क्राइब व्हाट different kinds of allocations are there, let me put it this way. जब आप main memory allocate करते हैं तो किस तरीके से allocate होती है, what are the different ways, और किस तरीके से deallocate होती है, और हम इसको इस allocation और deallocation के mechanism को use करते हुए अगर हम इस चीज़ को classify कर सकें किसी तरीके से, तो वो किस तरीके से होगा. जब भी आप कोई प्रोग्राम लिखते हैं, चाहे जावा में लिख रहे हो या C++ में लिख रहे हो, everything you write when it's executed उसको कुछ memory allocate होती है. जब आप integer I लिखते हैं, for example in your program int I, तो in main memory when it's executed I एक reference मान जाता है, एक उसके लिए integer की space allocate हो जाती है. ये तो हो गई passive allocation कि you didn't do any memory allocation, you left it to compiler. Compiler ने जब प्रोग्राम कंपाइल किया तो उसने कहा कि अच्छा ठीक है, ये इंटीजर है तो मुझे इंटीजर के लिए मेमोरी में एक स्पेस एलोकेट करनी है. दिस इज पैसिव एलोकेशन. सेकंड इज एक्टिव एलोकेशन. एक्टिव एलोकेशन इज व्हेन यू डू एक्सप्लिसिट मेमोरी एलोकेशन. एक्सप्लिसिट मेमोरी एलोकेशन में आप मैलॉक करते हैं. यू मेक श्योर दैट the variables you are declaring, the objects you are declaring gets what you are asking them for. I mean, they get the required amount of memory because your operations are memory dependent and you can't afford that maybe your variables will get memory or not and where they will be placed. You make sure that they get their memory, and for that you use malloc operation, memory allocation. The other side of it, that when you want to free those variables or the memory allocated those variables, you do a free operation. This is C++ context. So the difference here is that in malloc, your program or your process is explicitly doing a memory allocation and kernel cannot play with it. When you do malloc, if the memory is available, your process or your variables or your objects will be allocated that memory, and kernel cannot free it unless you explicitly tell your program to do so. And how do you tell it? You call it free, and then the kernel would know that now this chunk of memory is free to manipulate. So kernel has no jurisdiction on those memories that are allocated via malloc process. इसकी दूसरी साइड पे क्या है? दूसरी साइड पे those memories हैं which are allocated, or those memories which are not explicitly allocated, and these are managed by kernel itself. For example, अगर आपके पास मेमोरी में कोई एक पेज पड़ा हुआ है of all zeros या all ones, now kernel knows that this is a page that I can easily recreate when needed. So even if it is destroyed, there is no problem. Yeah, those memory allocations that are backed by files, we call it memory map files. That when you access a memory space, the contents are read from a file. So there is no point saving that content in the memory because all the content is present inside the file itself, and when a reference to that memory address is made, a file is read. So kernel can manipulate this memory according to the requirement. If memory need is higher, it may want to swap some, it may want to destroy some area, some memory allocation and create a new one, knowing that it can recreate the same space whenever required. Pehli type of memory where we are doing malloc is called a dirty memory. Dirty because kernel doesn't have any jurisdiction on it. The second type of memory where kernel can manipulate is termed as clean memory. So ये हो गया एक quadrant of memory allocation का. The second quadrant is more simpler, and it is divided as shared and private memory. Shared, as you can guess, is the memory that is shared among different processes, whereas private memory is the one which is allocated to only one process and only one process can access it. So these are the two axes of memory allocation, if you will. Memory can be allocated either malloc or it can be clean. And second quadrant, it can be shared among processes, number of processes, or it can be private to a given process. So these are the four quadrants. अब इसको देख लेते हैं कि एंड्रॉयड का प्रोग्राम या एंड्रॉयड का डेक्स स्ट्रक्चर जब एग्जीक्यूट होता है तो हाउ डज दीज क्वाड्रेंट्स प्ले अ रोल इन दैट. लेकिन उससे पहले हम अपनी हायरार्की देख लेते हैं कि व्हाट डू वी प्रेफर. हम प्रेफर क्या करते हैं? वी विल डेफिनेटली प्रेफर क्लीन मेमोरी, क्योंकि क्लीन मेमोरी कर्नल को स्पेस देती है टू प्ले अराउंड. It can see whether some memory is required, what is not required, and it can recreate pages on the fly. So it gives a room to play to the kernel, and kernel can decide how to allocate the memory itself. So we prefer clean memory. And we also prefer shared memory, because shared memory is accessed by number of processes. And so the memory price is paid by itself. Think of it कि एक आपने स्पेस एलोकेट की हुई है और वो सिर्फ एक प्रोसेस उसको यूज कर रहा है एज कम्पेयर टू एक आपने स्पेस एलोकेट की है जिसको नंबर ऑफ प्रोसेसेस यूज कर रहे हैं. डेफिनेटली यू विल गो बिकॉज योर मेमोरी इज स्केर्स नाउ. वी डोंट हैव अ लार्ज नंबर ऑफ चंक्स ऑफ मेमोरी अवेलेबल कि हमारे पास ये रूम हो कि जी हम हर प्रोसेस को उसकी अपनी प्राइवेट मेमोरी एलोकेट कर दें इवन इफ देयर इज नो नीड. वी हैव limited amount of memory and we want to utilize it as efficiently as possible. तो इसलिए हम clean memory को prefer करते हैं. We prefer shared memory, and of course clean, shared or private is more preferable than dirty, clean or private. इस memory allocation structure को हम जब एंड्रॉयड पे मैप करते हैं या एंड्रॉयड के डेक्स स्ट्रक्चर पे मैप करते हैं, डेक्स इज द फाइल दैट गेट्स एग्जीक्यूटेड एट द एंड ऑफ द डे. तो हाउ डज ये इसके डिफरेंट पीसेस इन क्वाड्रेंट्स में किस तरीके से फिट होते हैं? इफ यू थिंक ऑफ इट, हमने 4 बॉक्स बना लिए हैं. हमारे पास y एक्सिस है, हमारे पास x एक्सिस है, एंड वी हैव 4 बॉक्सेस देयर, ईच रिप्रेजेंटिंग डिफरेंट टाइप ऑफ एलोकेशन. One box where we have one box for private clean, we have one box for shared clean, we have one box for private dirty, and one box for shared dirty. So we have 4 boxes, and now let's see how Android fits in, and then we will see where do we get our efficiency from. जब भी आप कोई प्रोग्राम लिखते हैं, और क्योंकि हमने अभी एंड्रॉइड में तो प्रोग्रामिंग शुरू नहीं की, तो आई विल स्टिक विद द कन्वेंशंस दैट वी यूज इन C, C++ और जावा इटसेल्फ. तो how do we go about it? We start by declaring libraries. In C, we said include stdio.h or include iostream.h. या Java में हम imports लिखते हैं import java.io.star. तो हम सबसे पहले एक अपना लाइब्रेरी स्ट्रक्चर ऊपर टॉप पे लिखते हैं. उसके बाद we will have the main program that starts, और शुरू में उसके कुछ वेरिएबल डिक्लेयर करते हैं, और वेरिएबल डिक्लेरेशन के बाद वी गो अबाउट राइटिंग द लॉजिक ऑफ द प्रोग्राम. ये जो प्रोग्राम की लॉजिक होती है, दैट व्हेन द प्रोग्राम गेट्स एक्सिक्यूटेड, ये लॉजिक कुछ एक स्टेट क्रिएट करती है. जो आपने वेरिएबल डिक्लेयर किए होते हैं उनमें कुछ वैल्यूज जाती हैं. यू गेट योर हीप, योर प्रोग्राम गेट्स योर हीप, द प्रोग्राम गेट्स अ स्टैक. तो सम ऑफ देम इज लाइव स्ट्रक्चर, आई वुड से. प्रोग्राम के कुछ स्ट्रक्चर्स लाइव होते हैं, दैट इज व्हेन द प्रोग्राम गेट्स एग्जीक्यूटेड, उसकी एक स्टेट क्रिएट होती है बेस्ड ऑन व्हाट इज द वैल्यूज इनसाइड द वेरिएबल्स, व्हाट इज द हीप स्टेट, आप किस इंस्ट्रक्शन पे हैं. दीज आर द लाइव स्ट्रक्चर्स, और द कोड इटसेल्फ इज द पैसिव स्ट्रक्चर इटसेल्फ. फर्स्ट ऑफ ऑल वी हैव द मोस्ट प्रेफर्ड क्वाड्रेंट, दैट इज क्लीन क्वाड्रेंट. और क्लीन में हमारे पास प्राइवेट भी है और शेयर्ड भी है. तो अब अगर हमें अपना प्रोग्राम स्ट्रक्चर और इसको C और C++ या जावा के रेफरेंस से ही देखेंगे कि अगर हमने इन प्रोग्राम्स को फिट करना हो इन डब्बों में, तो हम किस तरीके से करेंगे. और हमारे पास सबसे पहले जो मोस्ट प्रेफर्ड क्वाड्रेंट है कि जी क्लीन, बिकॉज कर्नल हैव एक्सेस टू इट, कर्नल कैन मैनिपुलेट इट. और इस क्वाड्रेंट को देख लेते हैं कि इसमें हमारे प्रोग्राम किस तरीके से फिट होंगे। सबसे पहले ऊपर आपने लाइब्रेरीज लिखी। नाउ लाइब्रेरीज इज समथिंग दैट आर शेयर्ड अमंग डिफरेंट प्रोग्राम्स। आपके डिफरेंट प्रोग्राम, वही stdio.h जो है वो आपका प्रोग्राम भी शायद यूज करेगा। आपने शायद कल कोई प्रोग्राम लिखा होगा, उसमें भी आप stio या io stream यूज करेंगे। सो दीज आर द शेयर्ड लाइब्रेरीज, all coming from glibc, या in Android environment we are coming from libc. So these are the common files for the DEX, क्योंकि आपकी फाइल एग्जीक्यूट हो रही है उसके लिए कॉमन फाइल्स है। सो दिस गोज इनसाइड अ शेयर्ड क्लीन क्वाड्रेंट। इसके बाद आपकी कुछ एप्लीकेशन स्पेसिफिक फाइल्स है, आपका अपना कोड है, आपकी अपनी लॉजिक है। दिस गोज इनसाइड द प्राइवेट। अब ये दोनों क्लीन क्यों है? ये क्लीन इसलिए है कि बिकॉज दे आर बैक्ड बाय अ डेक्स फाइल। आपके पास अगर इफ कर्नल डिसाइड्स टू गेट rid of some of them, it can reload it back again because this is everything is coming from a dex structure. In case of shared libraries, जो आपकी libc है, maybe that is providing you support. In case of the variables और या प्रोग्राम की लॉजिक जो है, that is all stored in your program itself. तो अगर kernel wants to get rid of any one of them, it can do so easily because all of them can easily be brought back inside the memory. Everything is saved in files and from files you can bring it back in. तो ये हो गया हमारा क्लीन क्वाड्रेंट। अब हमारे पास दो बॉक्सेस रह गए जो कि हमने फिल करने। हमारे पास प्राइवेट डर्टी है और हमारे पास प्राइवेट शेयर्ड है। प्राइवेट डर्टी की बात कर लेते हैं। प्राइवेट डर्टी इज द बॉक्स जहां आपका सेफ हाउस है, जो आपकी एप्लीकेशन का सेफ हाउस है। आप यहां पर अपनी एप्लीकेशन स्पेसिफिक वो तमाम चीज़ें रखना चाहते हैं विच यू डोंट वांट एनी अदर प्रोसेस टू एक्सेस, विच आर वेरी स्पेसिफिक यूर टू प्रोग्राम। व्हाट गोज इनसाइड इट? आपकी एप्लीकेशन का हीप। नोबडी इज इंटरेस्टेड एंड नोबडी शुड बी इंटरेस्टेड इन योर हीप। आपकी एप्लीकेशन की लॉजिक में या आपकी एप्लीकेशन की स्टेट में नोबडी शुड बी इंटरेस्टेड। एंड द लाइव डाटा स्ट्रक्चर्स, जब भी आपकी लॉजिक एग्जीक्यूट करेगी प्रोग्राम में तो कुछ वेरिएबल्स में वैल्यूज जाएंगी, ऑब्जेक्ट्स की कुछ वैल्यूज होंगी, एवरीथिंग विल मेक अ स्टेट, सो वी विल कॉल इट द स्टेट ऑफ योर प्रोग्राम एंड दैट इज वेरी प्राइवेट टू यू एंड देयरफॉर इट विल गो इनसाइड द प्राइवेट dirty memory, because of course you would want your variable to have some space inside the memory and you can't let the kernel to manipulate it. Think about it. हम normally casual programming में तो हम int I लिख देते हैं and we assume that compiler will take care of it. लेकिन the best way to do is that you will do malloc to make sure that everything is properly given memory, and then at the end of the program you do free to make sure that the memory is properly deallocated, because even if one of the variables doesn't get the memory to execute, आपका प्रोग्राम वहाँ पे क्रैश कर जाएगा। आपने लिनक्स में अगर प्रोग्रामिंग की हो तो many times you see this error coming out of memory. This is because your variables are consuming so much of memory that your programs run out of space and it can't execute anymore. और जब अगर आप डेस्कटॉप इन्वायरमेंट में, लिनक्स जो मैंने एग्जांपल दी वो डेस्कटॉप इन्वायरमेंट की, तो अगर आप डेस्कटॉप इन्वायरमेंट में यू कैन रन आउट ऑफ स्पेस, देन मोबाइल में तो वैसे ही मेमोरी स्पेस बहुत कम है, तो सेम कैन हैपन देयर। तो प्राइवेट डर्टी इज योर बॉक्स जहां आप एप्लीकेशन का प्राइवेट डाटा, योर लाइव डाटा स्ट्रक्चर्स, आपने इंट आई अगर किया है तो इस वक्त आई में क्या वैल्यू है, आपने एक ऑब्जेक्ट अगर क्रिएट किया है तो उस ऑब्जेक्ट की इस वक्त प्रॉपर्टीज क्या है, आपकी हीप क्या स्ट्रक्चर शो कर रही है, आपके स्टैक्स क्या स्ट्रक्चर शो कर रहे हैं, दीज आर ऑल योर प्राइवेट मेमोरी। सो वी हैव फिल्ड 3 बॉक्सेस। हमने क्लीन वाला जो रो थी उसको भी फिल कर लिया है, हमने प्राइवेट डर्टी वाला बॉक्स जो है उसको भी शेयर कर दिया। अब हमारे पास एक बॉक्स रह गया और दैट इज वन दैट वुड वी probably would want to filled up, because this is better than a private directory, and that is shared directory. What goes inside shared directory? ये एक quadrant जो है, ये एक बॉक्स जो हमारे पास जो खाली रह गया, इसमें हम क्या चीज़ डाल सकते हैं? डेफिनेटली यू वांट टू पुट थिंग्स अप, लेकिन अब इसके नीचे जो है हमारे पास प्राइवेट डाटा है. वी कांट पुट दिस प्राइवेट डाटा इनटू अ शेयर्ड स्पेस. दैट डजंट मेक सेंस, because when we share it, every program would have access to it, and if every program would have access to it, that defies the security of the Android platform itself. So what goes inside the dirty shared space? Inside the dirty space we have a special process that is called zygote. What is zygote? Zygote is a early stage Dalvik VM. What zygote does is that it initializes a Dalvik virtual machine for you, and then it pre-initializes all the libraries that is needed. हमने शुरू में कहा कि जब मैं आपको Dalvik virtual machine से introduce करवा रहा था, तो I said that there is a huge set of libraries that is available for programmers use. सारी programming languages देती हैं, and Android is no exception. आपके पास C में you have a rich set of libraries for file operations, for input-output operations. In Java, you have a huge set of libraries to support different functions that programming language gives you. Similarly, Android gives you a huge library itself too, or इसमें its size becomes 10 to 20 MB at ease. So what zygote does is that it initializes your virtual machine, and then it also gives you a pre-initialized version of the library. It's kind of that you warm up the machine. It warms up the machine for yourself. आपकी इसी तरीके से है कि if you go to your office, and before reaching your office you call your secretary and say, okay, I'm reaching in 5 minutes, turn on my computer. And then you don't have to go through the hassle of waiting कि जी आप मशीन टर्न ऑन करें, उसमें वो बूट अप होगी, उसके बाद विंडोज़ की पूरी आपको स्क्रीन नज़र आएगी. दैट टेक्स सम टाइम, एंड आफ्टर 2 to 3 minutes you will be able to do something useful on your computer. You have to wait through the whole boot up process. Similarly, virtual machine ने भी जब भी आप एक नई virtual machine initialize करते हैं, तो it has to load up into the main memory, then it has to load all the libraries that are required for the functioning, and it will take some time. And to cut to that time, उस time को cut short करने के लिए the zygote process is there. The zygote process, first of all, initialize the virtual machine, the Dalvik virtual machine, and then it pre-initialize all the libraries that may be required during the execution. So एक specific set of libraries है which it loads up so that for better responsiveness. ताकि whenever you require a new virtual machine, it is given to you. And this is what resides inside the fourth quadrant, your shared dirty. The shared dirty quadrant or the box holds live DEX structures of these core libraries जो कि आपके लिए zygote process load करता है. Think of it, libraries तो it's a static thing. आपके पास core libraries होंगी, warm up किया Dalvik virtual machine के लिए zygote ने, and it loads all the memories for you. लेकिन then you use those memory structures for your program. And when you use it, आपने अपनी logic में उस libraries की functionalities को use किया, and you made some changes, and those structures became live because they have an state associated with it. And this is what goes inside the dirty shared memory. That now those applications, this is shared because these are core libraries. Everybody is sharing these libraries, but then there is live structure associated with it, and you can't afford to lose it. कि आपके पास kernel आए and kernel says, okay, I want to get rid of it, and I will later read it from the core library. It won't happen because it has a state associated with it. It's a live structure. Even though आप वो structure तो शायद या वो object तो जाके core library से दोबारा पढ़ लेंगे, लेकिन उसकी state जो इस वक्त current state है, you wouldn't be able to access it. So this is what Zygote does it for you, and this is how it fits the box for you. On slide I am showing you Zygote process relationship with other process. मेरे पास 3 applications हैं. I have map application, I have browser application and I have a home application. आप स्क्रीन पे देख सकते हैं कि in addition to their own data structures, at some point they refer to the core libraries that is loaded by Zygote. And this is the benefit of having a Zygote process, that now we have a shared space where the core libraries are shared. And this is how we get our memory efficiency, that we have set of core libraries that everybody shares and use it for their purpose without everybody loading their own set of applications or own set of core libraries for them. This is by dividing these memory allocations into different quadrants, this is how we get our memory efficiency in Dalvik VM, or now that I have introduced a new concept, Zygote. And I will go into the Zygote process in detail, that when we will see कि जो Android का system है वो boot up कैसे होता है, और how will it takes, I will take you through the steps, how the libraries are loaded and where does Zygote play a role and where does Dalvik come into the action. Lekin for the time being, it's important to understand that Zygote loads up core memories for the processes, and these are the core memories that give you memory advantage, or these are the core memories that give you memory efficiencies in executing a process or executing an application. ये तो हो गया हमारे पास memory efficiency. अब दूसरी dimension which is not that important but is important is the CPU efficiency or the execution efficiency. अब बात वही है कि हमारे पास जो मोबाइल फोन है, they are compared to the desktop environment that we used to have 10 years back. हमारे पास CPU speed in a typical mobile phone is probably 250 to 500 megahertz as compared to आजकल जो हमारे पास desktop है, they are working on gigahertz probably नहीं, for sure they are working on gigahertz. लेकिन हमारे पास अभी जो mobile environment है, we are still on megahertz. We have bus speed, very small bus speed and almost non-existing data cache. और ये सब restrictions and on the top of it हमारे पास RAM बहुत कम है. We are वो सारी high level की memories load कर ली हमने, उसके बाद low level memories load कर ली, उसके बाद हमने program structure load कर लिया, libraries load कर ली. ये सब कुछ करने के बाद हमारे पास अगर वो वही example को लेके चलें, 64 MB RAM के concept को लेके चलें, तो हमारे पास almost 25 MB RAM हमारे पास बाकी बची हुई है. So this is the environment we are working on. तो इसमें हमने पहले ये देख लिया कि हम मेमोरी को किस तरीके से एफिशिएंट कर सकते हैं, मेमोरी एक्सेसेस को किस तरीके से एफिशिएंट कर सकते हैं, किस तरीके से हम लाइब्रेरीज को शेयर कर सकते हैं सो दैट दे डोंट टेक अप एक्स्ट्रा स्पेस. अब दूसरे डायमेंशन देख लेते हैं कि हम सीपीयू या एग्जीक्यूशन किस तरीके से एफिशिएंट करते हैं. इसके लिए हम 2-3 टेक्निक्स यूज करते हैं, एंड आई वोंट गो इनटू डिटेल बिकॉज इट्स डिटेल इज part of computer architecture course per se, lekin just to quickly give you an overview what is how the CPU efficiency is gained. सबसे पहले तो एक डिसीजन जो एंड्रॉयड ने किया, बड़ा ड्रास्टिक डिसीजन था, that they wouldn't give you just in time compilation, जिसको हम JIT compilation कहते हैं. ये एक जावा के प्रोग्राम्स की बड़ी एक या जावा एनवायरनमेंट की एक बड़ी स्पेशलिटी थी, जस्ट इन टाइम कंपाइलेशन. और जस्ट इन टाइम कंपाइलेशन पर्पस ऑफ JIT compilers was to give you efficiency, speed efficiency. It will give you speed boost. एंड्रॉयड ने शुरू में डिसाइड किया कि नहीं, हम वी वुडंट हैव जस्ट इन टाइम कंपाइलेशन. और क्यों इस चीज़ को ऑप्ट किया गया? जावा और एंड्रॉयड का जो इस पर टेक था वो ये था कि ऑल द हैवी लिफ्टिंग इज बीइंग डन इन कोर लाइब्रेरीज. जैसे कि हमने जब लेयर्स पढ़ी तो मैंने आपको बताया कि दीज लाइब्रेरीज आर द वंस दैट डू द मोस्ट ऑफ द हैवी लिफ्टिंग. तो तमाम फंक्शनैलिटीज आर इम्प्लीमेंटेड इन नेटिव C++. ऊपर जावा की लेयर में जब हम एप्लीकेशंस लिखते हैं तो व्हाट दे डू इज दैट दे मेक रेफरेंस टू दोज कोर लाइब्रेरीज. आपने अगर मूवी चलानी है तो यू विल मेक अ रेफरेंस टू मीडिया फ्रेमवर्क. आपने अगर परसिस्टेंस करनी है तो यू विल मेक अ रेफरेंस टू SQLite. And all of these libraries that are mentioned are implemented in native layer, in native C++. तो Android के टेक इस पे ये था कि चूंकि हम Java में we are not making any heavy lifting, we are doing all the heavy lifting in C++, so just in time compilation wouldn't make a lot of difference. That was their stand at that time. Of course, things changed, and then as of Android 2.2, just in time compilation is back into the Android scene. लेकिन ये जब Android रिलीज हुआ तो एक उन्होंने रीज़न जो है उसकी जस्ट इन टाइम कंपाइलेशन को ऐड करने की ये दी कि इट वुडंट चेंज एनीथिंग फॉर एंड्रॉयड. अब स्पीड एफिशिएंसी गेन जहां से आया, मतलब एक चीज उन्होंने निकाल दी कि उनका जी जस्ट इन टाइम कंपाइलेशन हमें नहीं चाहिए. हम they said that we will get the speed efficiency from installation time verifications, not runtime verifications but installation time. कि जब एक एप्लीकेशन इंस्टॉल होगी तो we will do all the heavy lifting. उस वक्त हम वेरीफाई करेंगे कि हमारे एड्रेसेस वैलिड है इनसाइड द पैकेज, हमारे इंडेक्सेस वैलिड है, एवरीथिंग इज पॉइंटिंग टुवर्ड्स द राइट थिंग. बिकॉज आप अभी जब हमने डेक्स फाइल को डिस्कस किया तो हमने ये कहा कि नाउ इट हैज लॉट ऑफ रेफरेंसेस इनसाइड, लॉट ऑफ पॉइंटर्स गोइंग आउट फ्रॉम वन प्लेस टू अनदर. So Android said that okay, on install time we will verify everything. We will verify that all the memory accesses are safe, all the references are safe, and this is not for security purposes. Security is Android is given from process isolation. Our processes को isolate कर देते हैं. One process can't access the data of another process, and this is the basic structure of Android security. This verification is for bug-free purpose, to make sure that your program is bug-free. So everything is what your DEX architecture is what it says. ये तो नहीं है कि कहीं पे आप you are trying to reference something that is you are not supposed to do that. आपके कहीं पे reference खराब तो नहीं हुए. So it do all these verification process during the installation, so that when you run it, you don't have to do it all over again. This ensures that your code is bug-free, so that it doesn't misbehave. So this is one thing that Android did for speed efficiency. In addition to this, we have byte swapping. The concept of byte swapping is that we all know that an integer takes about 16-bit. 16-bit integer takes about 2 bytes inside an architecture. लेकिन इसका जो orientation है, that is not fixed. In some computer you start from left, in some computer you start from right. And this is where your big endian and small endian comes into play. और होता ही है कि जब अगर आप दो डिफरेंट आर्किटेक्चर्स के दरमियान में डाटा ट्रांसफर कर रहे हैं, यू विल हैव प्रॉब्लम, बिकॉज इन वन आर्किटेक्चर यू विल थिंक दैट ओके डाटा इज गोइंग फ्रॉम लेफ्ट टू राइट, एंड द अदर आर्किटेक्चर इज अज्यूमिंग दैट डाटा इज कमिंग फ्रॉम राइट टू लेफ्ट, द अदर वे अराउंड. So byte swapping is built inside the Android itself. Then we have padding. Padding gives you easier pointer access. Your pointer mathematics is easier. That adds up to the efficiency. Then when a DEX structure comes in, it contains a lot of symbolic references. What your installation time does is that it creates a lookup table out of that reference. Lookup table का क्या फायदा होगा? Lookup table का ये फायदा होता है that now you have indexes for everything that is referred inside the program. आपने अगर function call करना है तो instead of कि आप उसे search करें through different references, आप directly उस जगह पर jump करते हैं, you call the function and you execute it. So आप वहाँ पर time save कर लेते. So these are the few enhancements that were done in order to gain CPU efficiency or speed efficiency. We will continue discussing this efficiency phase, especially the speed efficiency, in our next lecture. We will discuss कि after byte padding, after byte swapping, after padding, after this inline structuring, what other mechanisms were used to, or we will discuss these mechanisms in a bit more detail to see how the speed efficiencies were gained inside the Android. Till then, I'm Abdul Aziz signing off. Allah Hafiz.